Good afternoon, everyone. It's really pleasure for me to introduce one of collaborators from University of Missouri. First of all, this is Evangelos Kaiser, the director of the Frame Mobility Research Institute. It's our pleasure to introduce Dr. Yaw Adu-Gyamfi. He's an assistant professor in the Civil and Environmental Engineering Department at the University of Missouri, Columbia. He received his master's and doctoral degree in civil engineering from the University of Delaware. His research includes sensor fusion, computer vision, machine learning, and big data analytics. And he is going to talk to us about the work that has been sponsored by the FMRI and the US DOT on development of web platform for visual analytics of rail data. Before we will start, I would like to thank the IT FAU student chapter that they help us and put this webinar together. And since this, I would like to ask Juan to present this great work that will be very beneficial, for many DOTs. And I think we use data also from Florida, if I'm not mistaken. Yeah.
Yes. Yeah. Thank you, Evangelo. As you said, my name is Yaw, and I think we started this work maybe about 2 years ago. So you will hear me talk about visual analytics a lot. And so I thought it will be good to basically explain what that is first and foremost. So visualization, we know, and that is usually easy to do in the web browser. I think visual analytics, on the other hand, looks at not being able to just visualize the data, but also being able to analyze it, all in the web browser. So you can do aggregation, you can filter everything in the browser. Now it's challenging because the browser is not as powerful to do computations. And so the goal here was to bring different data sets, free data sets together, and then build a platform that you can use to basically visualize and analyze the data at the same time. All right, so right here, what I'm doing is I'm showing you a visualization of freight flows across the country. Okay, so each link, basically each OD has a link that connects them. At the same time, you can see other, give me a second, let me. At the same time, you can see other measures. For instance, I have here a chart of total tonnage by commodity type. I have total tonnage by OD type. They're just different measures that I'm looking at. So since I'm gonna assume that I'm in Florida, I'm just gonna click on Florida. Okay. Now, when I click on Florida, I expect everything to change. Okay, now that's very fast. It basically, the map updates to just Florida and all flows in and out of Florida. Okay, you can quickly see that, of course, most of the flows are within Florida. Okay, and that's basically some of tonnage by destination. So this is basically, and I think the next place Florida ships mostly to is Georgia. Okay, and if we click on Georgia, you can see which locations. So it mostly goes from Tampa to Savannah, Tampa to Atlanta, and then Jacksonville to Savannah. So you can see all the places that the origin and destinations. You can also see the mode. So mostly you use truck to transport, which makes sense. Now let me You can also look at what is actually being transported. Okay, so other foodstuffs, mixed freight. So there are just different things you can look at. And if I say, okay, I just want to focus on things that are transported by truck, it will basically update everything to just things that are transported by that. Okay, you can clear this and look at other destinations. Say we want to go to California, and everything else updates. So you're looking through your data set quickly without all these latencies. And really, so if it gets to a point where things are getting slow, let's say if the data gets too huge, the simplest way to make this fast is just add another GPU. Okay, so as you increase your GPUs, if you add another GPU, it just makes things faster. But yeah, so that's kind of that with this data set, right? So you can look at different things, what commodity type is being shipped, and the different dimensions of your data set can be visualized. Let me look at another visualization that I have, which is very particular to Florida. Second. So here I visualized so if you look at this map, you have your routes, the interstate routes, and then you can also see the way in motion sensors on these routes. Okay, we basically here we're looking at the track, each track that passes through this way in motion sensors, whether they're full, how many percentage that's full, percentage that's empty, half empty, cubed out. This is by direction. And you can look at different dimensions of the data. So this heat map is looking at the month by hour, the gross weight. So you can see that during the day, the gross weight goes down. And most of the tracks, I guess, with full loads are usually coming in early in the morning or late at night. So this is looking at it by count. So it looks like the count, you do have more vehicles during the day, but the weight is mostly at night, not dawn. Now there was one interesting thing. Let me go back to this and select. So mostly I think that the southbound tracks are bringing stuff in to Florida. And you can see almost about 50% of them are full. 14% are cubed out, which is pretty much, so I would say about 60% are bringing stuff to Florida. Okay, only 21% of the southbound tracks are empty. And you can, so now that I selected southbound, everything here has updated to just southbound goods. Okay, if you look at this, this heat map, that's the average gross weight by hour and month. So if you look at it, and I think from October, November, December, it looks like the weight, there's always something coming in throughout the day. And the pattern kind of changes from January to, I think, September. But generally, you will see that there is less stuff coming in at this period from 8 to 4 p.m. Most of the stuff are coming in after 4 p.m. You can look at things by month. And if you look at these plots, this is basically the hourly counts. Okay, and obviously you can see it goes up, getting toward Christmas, and then after that it comes down. And it's So since we're looking at things at the hourly level, this is about, I mean, you're looking about 30 million rows of data in the browser. Now, so south brings in stuff. If I go to north, so north, you can see most of often the northbound tracks are empty. Okay, so they leave empty. Very few of them, 30% of them are usually full. And you should see the charts also updated, each of them updated just to reflect that. Okay. Now, the variations, I mean, these charts are very different depending on where the way station is located. If I zoomed into this particular way station, right, so that way station, if you look at northbound, 52% of the tracks going through this northbound out of the state are empty. And then if you look at the southbound, only 21% are empty for this particular way station. So you can look at, you can analyze this, I mean, at a very local state scale, and you can also analyze this on a global for the whole state. And you will notice it really varies a lot. I mean, these charts varies a lot depending on where the way station is. What I noticed though is that most of your way stations on the freeways, the empty tracks, there are a lot of empty tracks when they're going north, up north. Let me see if I can show one more. Yeah, let's see this one. Okay, so this flips. This has, yeah, when it's coming south, so this is south selected. Let me clean this again. So when it's coming south, 53% full. Okay. Now, if you do north, almost 70% of the tracks going through that spot up north are empty. Okay. So that's pretty much this. So this is also looking at just, I mean, it's looking at one data set, just your way in motion data. Now there's another dashboard that we have that will look at both the way station data and then another data set. So give me a second, let me show that one. Now, once you start integrating the data sets, you're using a lot of data. It gets really huge. Now, so if you can see that map, that's basically the red squares are your way station sensors, and the circle dots are basically your freight facilities. Okay, so for instance, if I just wanted to look at the locations of all the bottlers, so the bottlers comes from the way, I mean, the freight facility centers. So you can see the dots basically updated to just bottlers and let's say heavy manufacturing locations. So those are the locations of all heavy manufacturing locations. And notice my speed graph will change. So these are the speeds at the way station locations. And you also have your gross weights. And you have all these other charts that are looking at what is going on at the locations where you have heavy manufacturing. Now we have here proximity. So this is proximity to the way station. So if, for instance, you only want to look at way stations that are 20 miles away from a way station, that should update to only freight facilities that are within 20 miles to a way station. Okay. And you can move this. We can also look at, say, condos that are really, really far from a way station. Okay, so it basically only shows you here on the map freight facilities that are really far from a way station. Okay. And the speeds around those way stations are also indicated right there. And you can see what types of, what are the land uses in those areas. And you can see the gross weight by direction here. Yeah, so it gives you a good picture. You're able to analyze, look at the different data sets in one dashboard. Now, so when we're working on this, we came to a point where I still felt, okay, the freight data we have right now is not big enough. I really wanted something that could challenge the platform. Now, I think the track GPS data would have been a good one, but we didn't have access to it. But recently, we looked into a connected vehicle data, which is from Wejo. And I basically tried visualizing that also with the same data. And I think, especially with this platform, having GPS data will be very, very helpful and easy to explore the different trajectories of tracks and the performance of the system. Now I can show you one last one, which is the connected vehicle data. So this data is from Missouri. So let me zoom into St. Louis region, which has lots of data. Okay, now here is basically the locations. And this data has other stuff, like it has like hard braking events. It has so much data, but in this case, I was just visualizing just the locations and their speeds of the vehicles. And this chart right there is just looking at the unique vehicles. And I'm just visualizing a few of them. There's just a bunch. When you move to different locations, they will change. Okay, so so I usually just show a few of them, and then once you move to different locations, the unique vehicles will change. So let's say I just want to look at one particular route, I-270, which is a very popular route in Missouri. Now you can see different vehicle trajectories. So I can click on this one. This is just one vehicle's trajectory. I can click on different ones. That one is another vehicle. You can look at different other vehicles and their trajectories. And you can see wherever you see the greenish, yellowish dots, it's basically the slowing down. So you can pretty much see the performance where the brakes are, where they are stopping, the performance of the whole route by just this. So you can look at different. So let me use this. Now, because of privacy, so if you can look here, this is basically a plot of my speed. Now there is a gap. So it looks like at 8 a.m., there was data from 8 a.m. to somewhere around 10 for that vehicle. And then they didn't collect any more data until the evening after 8 p.m. The reason is for privacy issues. They don't want you tracking a vehicle throughout the city. So they give you the trajectory, and then for a period of time, and then they break it, and they don't send you data until another time. And then, so there are all these breaks in there, but still it captures, you can capture the performance of your system. So this is basically looking at it from, I think, 8:25 to almost 9 o'clock. And you can see the speeds of that vehicle over time. And you can basically draw something here. So that should show you where it was at that time. And you can move this, and that should move. The map should show it moving. Okay, so this is where basically it stopped. And you can look at basically the trajectory over certain distances. So this was a good test. This was a good test of the platform. And I believe as the data sets that we need to compute performance measures or understand our system grows, there is a need to have platforms like these that can help you look at your data quickly. Without having to have someone always like write codes to pull data and do all these computations. This can be done for you once. And if the data is the same, you never have to do this again. The data comes in and these visuals will just update based on the data that comes in.